Question 19 says Andy has some counters. 15% of the counters are red, 2/5 of the counters are blue, and the rest of them are yellow. There's 27 counters which are yellow. How many blue counters are there in total? So, because I know the amount of yellow counters and the other ones I'm given what proportion of the counters are red and blue, what I really need to know is what proportion of the counters then are yellow. And then I can use that and set up an equivalence with 27. So, starting then with red, well I know 15%, I've just written that down. Red is 15%. Let's do all the rest in percentages. 2/5 of blue, well 2/5 of the percentage is 40%. So red's 15, blue is 40, that totals 55%. Well, if 55% are those two colours in total, then, and because the remaining ones are yellow, that means the yellow ones must be 45% in order to add up to 100. So now I can say the proportion of yellow counters is 45%, and I'm told how many that is, 27. I set my equivalents up. 45% represents 27 counters. Now I want to find how many blue counters there are, so I'm after 40%. So if I've got 45 and I want 40, just thinking of the link between 45 and 40, what other number could I work out maybe in between? How about 5%? So just dividing by 9, I work out 5%. 27 divided by 9 is 3. So if 5% is 3 counters, I can now work out 40, either by multiplying this by 8, and doing the same here to get 24, or I could have done 45 take away 5 is 40, and likewise 27 take away 3 is 24. So the number of blue counters is 24. Question 20 talks about a lawn with a path around it, and it's looking at paving slabs. I want to work out how many paving slabs I will have around this lawn. You can see I've just split this up to begin with. I've just split this going across here like this into 4 different sections. Okay, and I've also just put on here that the distance here is 0.5 because that's the width of the path all the way around. So I'm just going to work out how many slabs I need in each of these sections and then add them together. So starting with section 1. Well, because the paving slabs are each 0.5 by 0.5, well, that's 0.5 there, so that would be like 1 slab. Okay, I want to work out how many I'd have across in total. So what I'm going to need for this is the total distance across. Well, the lawn I know is 8 metres, and this bit's 0.5, and so is this. So the total distance across must be 9 metres. And I want to know how many of these 0.5 metre slabs I can fit into this 9 metres in total. So how would I work that out? I would do 9 divided by 0.5, which is 18 slabs. Okay, so I can fit 18 slabs into section number 1. Well, look at section 2. It's exactly the same size as section number 1. So if 18 slabs fits into this top section here, then there must also be 18 slabs in section number 2. Let's now just look at section number 3 here. Again, 0.5 going across like that. And I just need to then work out then how many of the slabs I can get in between here and here. That distance is 6 metres. So how many 0.5s fit into this 6 metres? Again, I'm going to do this calculation. 6 divided by 0.5, which is 12. So that means 12 slabs fit into section 3. And because section 4 is the same size as section 3, 12 slabs fit into section 4 as well. And I want the total number of paving slabs I've used, so I've got to just add all these up, which gives me a total of 60. So 60 slabs. Question 21 is a scale diagram. So we're told the distance A to B and B to C, and which is already drawn on for us. And we're told that point B is due north of point C. We're given a scale to use and then a bearing and another distance A to D. We want to mark on the position of D. Okay, now your answer is going to look something like this. I'm going to explain where I've got this from in a moment. Firstly, for this to be accurate, the scale, because the scale is 1 centimetre to 50 metres, I needed this to be on A4 paper in order to draw it like this. If you haven't got it on A4 paper, it will look something like this, but it might just look a tad different on how it fits on the paper. Okay, so just using the information that I was given in the question. Starting with this line here, the bearing of D from C is 260 degrees. So I'm going from C, so that's where C is. So I start from there, and I'm going on a bearing of 260. So I need to use my knowledge of bearings. Well, I know that bearings always start by facing north, and I know bearings always turn clockwise. So I get my protractor, like so, put the cross there on where C is, line up the 0 at the top, and then you can see the numbers on the outside are going up. So I'm going to turn clockwise. So let me do this again. Turning clockwise on the outside there, and I want to make my way round to 260, which is there. Okay, there's 260. So I've just made a little bit of a mark there on my paper. Okay, like so. So I know that D is going to be somewhere on this line. Okay, when I drew it. Now I just need to use the other information about whereabouts it was on that line. So I was told that A to D is 480 metres. Okay, now if I just started with that piece of information, I would know that it would be somewhere from A fixed at 480 metres, but I don't know where. So using the scale of the diagram, I was told 1 centimetre represents 50 metres. Okay, and AD is 480 metres. I've just set up an equivalence here. 1 centimetre represents 50 metres, and I've got 480 metres, so I just needed to work out, well, what do I multiply 50 by to get 480? It's 9.6. This is a calculator paper, so I would have just done 480 divided by 50 to work that number out as 9.6. So that means 480 metres is 9.6 centimetres. Okay, so I knew I was going to draw a line with my ruler from point A of 9.6 centimetres. Now, to make sure I had a rough idea whereabouts it was, I need to use a compass. So I get my ruler, do this down here, get my ruler, and I opened it up, put the point there and just opened it up to 9.6 metres. Do this accurate. 9.6 metres you can see there, okay? So that is 9.6 metres open. I then got my compass, put the point on at A, and then I just made an arc like so, somewhere around here, okay? And by doing that, I know that point D lies on that arc, okay? So point D I knew lies on this arc, and then I also knew that point D would lie somewhere on this line. So where this arc and this line intersect, which is here, is where point D must be. Okay, and then I've just drawn a line from A to D just to make the shape of the field, the quadrilateral field. And if I check with my ruler, that distance should be 9.6. I've done it right, which it is. And if I can, well, I can just check this angle again, but that should be on the bearing of 260, which you can see it is. So there it is. That's my answer.